Bueno, espero que os haya gustado la charla tanto como me ha gustado a mí y vamos a pasar con el turno de preguntas. Antes queremos agradecer a Intelligence que sea nuestro sponsor en este evento y que nos haya acompañado como sponsor desde el primer meetup. Intelligence, en plena pandemia, además de lo que venían haciendo anteriormente con desarrollos de software, ha seguido trabajando en su línea de desarrollo de inteligencia artificial, perfeccionando mucho más su metodología y arquitectura propia, hasta el punto de ser reconocidos con el IDC Innovator y tener un proceso de automatización único combinado con sistemas de predicción inteligentes IPA. A día de hoy, no solo lo automatizan todo, sino que llevan sus soluciones a producción. Se centran ahora tanto en el desarrollo web como en la inteligencia artificial, todo bajo la figura de un equipo de dominio, ganándose así la confianza plena del cliente de forma más rápida y eficiente, pudiendo ayudarle en todos sus retos de negocio. Son ya 160 personas y trabajan al 100% con trabajo híbrido, remoto o presencial en Madrid, San Francisco y otras ciudades. Las personas trabajan desde donde quieren. Van a la oficina de Callao, su sede en Madrid, o a San Francisco, su filial americana, cuando ellos quieren y lo necesitan, de manera que han conseguido flexibilizar aún mucho más el día a día. En Intelligence ya venían haciendo esto desde hace años, construyendo una cultura de work-life balance. Han mejorado los planes de carrera internos, ofreciendo muchas más opciones de crecimiento a todos los niveles. Engineering, Management, DevOps, Data Scientist, Machine Learning Engineers, aseguramiento de la calidad, arquitectura, análisis funcional, etc. En este enlace podéis ver los perfiles que necesitan ahora mismo. Hey everyone again, here we are for the Q&A session with Jochen Babakin. Please write your questions at the Zoom chat and we will read it for you, or raise your hand at Zoom and we will give you access to talk. Meanwhile, our attendees ask you, I'd like to ask you some questions. It is nice to have people like you in this competition defending us from deepfakes, but on the other hand, it seems that the stronger is the current detection, the better will be future deepfakes. Is there a solution to this problem?
Yeah, you're right. So basically, we have this like continuous battle of like generation and detection, and probably this battle is kind of like similar to what we have in this GAN networks, where we have generator and discriminator. And I'm afraid that building these like good working solutions, we're kind of like increasing the quality of the discriminator, and it allows like to reuse these like detectors for their deepfake generation, like to improve the quality of the deepfake generation. And I would say that now like generation is kind of like winning this battle, and probably we will have hard time to kind of detect all the possible types of the deepfakes. And for me personally, I decided like not to take part in any of these like parties. So I decided not to like neither detect nor generate deepfakes, as you still kind of like improving these like generation techniques. And it is kind of like more personal choice rather than the technology.
You choose the right way. It seems that the bad guys have the advantage in this game. But
Yes.
anyways, deepfakes are intended to mislead humans. Could deepfakes be improved with an adversarial attack in order not to be detected by systems like these ones that you have described before? Are there currently any non-differentiable mechanism for deepfake detection?
Yeah, you're right. So like this adversarial attacks could be another source to like fool the detectors of the deepfakes. And from my point of view, it is still not that easy as in the usual image classification. So I guess all of you have seen this example when you could change just a couple of pixels in the image, and the ImageNet classifier, instead of like predicting one animal, predicts completely another animal. And here we have only two classes, so it is just binary classification, whether it is fake or not fake. And that is why it is much harder to kind of like switch predictions on the contrary while changing only a small portion of the pixels. However, these adversarial attacks could be applied for like face detectors, I mean, in order to detect the deep fakes, we firstly try to locate the regions of the faces. And probably it is easier to kind of like fool these detectors and maybe draw some additional pixels that the detectors will just fail to find the faces. And during the competition, there were like funny examples when, for example, there was a person in a video and the person has like a print of like a face on the t-shirt, and the model treats this like printed like face as a real face and tries to detect the deep fakes there. And that is why, yeah, we could fool these like face detectors. And speaking about non-differentiable methods, I still think that now deep learning kind of like leads this area of like in any applications of, I mean, like classification, detection, segmentation, and so on. So it overperforms like classic computer vision methods. And yeah, I would trust, I would believe in deep learning.
Perhaps you could use like unconditional input for the GAN to force it to blink once or twice during the. I don't know. I don't want to give bad ideas. No, please keep going on.
Yeah, it's
yeah.
Sorry.
Go ahead. Go ahead.
No, yeah, I just wanted to ask you a question from someone in the for the public. He says, "Okay, thank you, Johan. Could you elaborate a little bit the 3D CNN approach?"
Yeah, all right. So the idea here is that as they're like in the usual images, in the usual two-dimensional CNNs, we have just two dimensions, like width and height of the images. And we apply our convolution. So our convolutional is just like two-dimensional matrix. And then this matrix is applied through all the channels. So basically applying the same transformation to all the channels. And in three-dimensional CNN, the idea is that now we have like 3 dimensions. And as an input, we have like, for example, some volume. It could be a stack of images, or it could be like three-dimensional volume in some medical images, like CT scans, for example, where we have width, height, and depth. And in this case, you're applying like 3-dimensional like matrices. So instead of applying like just the usual standard 2-dimensional like convolution, we'll apply 3-dimensional convolution, and it will apply through the whole like depth of the input, and it allows us to kind of like simultaneously work with different number of channels and different depths. And it kind of like helps in their use cases where you have this like kind of domain where you could use a 3-dimensional like space, right? So as I said, it is either video processing when we could just stack the whole stack of frames in a single input, or it is most frequently their medical images with a depth dimension.
Okay, thank you. We have another question.
Yes, Álvaro Barbero is asking about the autoencoders. He wanted to know if the autoencoders approach for deepfakes generation, does these methods include any kind of constraint to ensure that the latent space produced by different autoencoders are similar?
It is a good question. So basically, the idea is that we're training them in a way that it is their like the common latent space for both input images. So it means that we just sharing the weights in the encoder, and it means that after we are passing, thanks for the image. So after we're passing the faces through the encoder, we have the shared weights there, and they're also updated simultaneously. And that is why this latent representations, they are basically already in the same space. So it means that we don't have like similar spaces here. We just have the exact same space for both faces. And the idea here is kind of like this Siamese neural networks, when we have like two independent branches, but basically they share all the weights. And once you update one branch, it also updates the weights in another branch. And that is why the training simultaneously here. Yeah, hopefully I have answered it.
Yeah. Very interesting, the question and the answer. Let me tell you one more question. You said at the end of the presentation that nowadays it's easy to make a detector if the data set is provided, but not so easy if you have a real or different data sets. What do you think we can do to make a more general detector deepfakes?
Yeah, I think that it kind of like the problem in all the deep learning applications right now. So if you have enough data, then you could solve basically any problem as long as the human could like distinguish something in the images or in the video, and you have enough data, then we could train such a system. And the problem with the deepfakes is basically the limited data sets. And as I said, like one of the like major kind of like advantages of this competition was actually releasing of the data set. So it kind of like should help their community, their like research community, to build better generalizable deepfake detectors. But the problem still exists, right? So even for this large data set with hundreds of thousands of videos, it is hard to still generalize to some like super new type of the deepfakes. And I think that the only like solution here is just to try to collect and generate more data. So once we see any new type of the deepfakes that have super cool quality, then we just go ahead and try to generate as many possible training examples and retrain our like deepfake detector in order to catch up with the new advancements. So yeah, I guess the data is the only
okay
exit. Yeah.
We have one more question for an attendee. We will see a winner solutions in Kaggle without an XGBoost at top. From his point of view or her point of view, there are very smart approaches, but simply they don't outperform these models. What do you think?
Yeah. Again, so it is basically the limitation of Kaggle, right? That nowadays, and I guess it was previously with tabular competitions when there were like in the end of their like all the competitions, basically like stack of large ensembles of XGBoost and LightGBMs were winning the leaderboard. And now it is true also for the deep learning competitions. So basically, we have all the pre-trained models now. We have both for the images and for the texts. And in the end, all the solutions are pretty similar. But I still think that Kaggle is kind of like a place where the new approaches are also appearing as well. And I guess XGBoost like has achieved its popularity exactly after the Kaggle competition. And it means that, yes, it is like new approaches are usually kind of worse than their well-established ensembles. However, there are appearing sometimes the methods that kind of like drive their research and drives the whole machine learning area. Yeah, starting from the Kaggle.
I have a very last question to end this Q&A session. Please install your quizzes application and sign in with an email address, because we are going to start soon with the quizzes. And the very last question was that I have heard that this Kaggle competition also had audio effects. Did it happen like this? And if yes, could you please share the details?
Yeah, so basically in this competition, the organizers said that there were like apart from the video deepfakes, there were also audio deepfakes where they modified their voices of their like again they had like the source and target persons and they were modifying their voices. And the approach there was also similar to this encoder-decoder approach when we just substitute their one person with another. And basically we have tried a lot of like we have invested a lot of time in order to detect these audio deepfakes. And the approach there is pretty similar. So now all the audio like classification problems are solved using their like MEL spectrograms. So basically it is image representation of the audio. So it is still their image classification problem in the end. But it didn't bring any value for us in the leaderboard. And I guess none of the winning solutions were also using the audio deepfake detection. So basically all of them were based only on the video.
Okay. It is quite interesting. Thank you very much, Jochen.
Thank you very much.
Thank you.
Very, very interesting, both of them, presentation and questions. So let's go now for the machine learning quiz. Tenéis que verlo en vuestro terminal. Bueno, ahí tenemos liderando, me ha parecido ver a Ricardo Guerrero. Vamos por el siguiente. ¿Cuál es el accuracy score en esa matriz de confusión? Vamos, seguimos a por el siguiente. Vamos a por la siguiente. Hemos visto la presentación de Jochen. Bueno, todo el mundo magnífico, ¿eh? Vamos a por la siguiente. ¿Qué función de activación es? Hay que mirar bien la imagen. Bueno, está muy reñido, por arriba, ¿eh? No nos hemos fijado bien en el eje de ordenadas. ¿Qué frontera de decisión de las 4 que se muestran es un árbol de decisión? Bueno, tenemos 3 arriba. Vamos por el siguiente, que empieza el Partido España, vamos. Bueno, el cambio de liderazgo. Vamos a por la siguiente. Solo había uno que tenía dimensión 1 de profundidad. Bueno, muy reñido, ¿eh? Vamos a por la próxima. Nos referimos al cuadro rojo, ¿eh? Vamos, creo que quedan 5, ¿eh? Bueno, los dos Álvaros arriba. Vamos. Hay que tener en cuenta los pesos y los vallas. Vamos. Álvaro Barbero primero. Vamos a por la siguiente. Vamos a por la siguiente. Luego miramos el leaderboard, que queda un mal de tiempo. Álvaro sigue líder y Alberto segundo. Álvaro primero, segundo Marcos. Vamos a por, creo que es la penúltima. Álvaro primero, Marcos segundo y creo que es la última, ¿eh? Atentos. Pues enhorabuena, creo que era la última, ¿eh? Vamos a darle aquí. Enhorabuena, creo que Álvaro era la última, efectivamente. Álvaro Barbero, enhorabuena.
Enhorabuena, Álvaro.
Muy bien, hombre, pues enhorabuena y te enviaremos lo prometido, ¿no? Álvaro primero, Marcos segundo, Jaime tercero, ¿eh? Enhorabuena porque no era nada fácil.
Yo he visto la cosa muy reñida, ¿eh?
Está muy
Y hay
reñido.
que tener en cuenta que estas aplicaciones no solo tienen en cuenta la respuesta correcta, corrígeme Javi si me equivoco, sino también el tiempo que tardas en contestar. No sé si se la han jugado un poquito ya al final a ver quién contestaba más rápido.
Pues bueno, pues enhorabuena a Álvaro y bueno, y a Marcos y a Jaime. Pues Virilo, si quieres ya cerramos, que
Sí,
empieza el
sí, pero
partido.
antes de cerrar, sí, por supuesto, el ganador de este quiz se acaba de llevar una tablet, una Samsung Galaxy Tab A7, si no me equivoco, y tenemos otra para el mejor clasificado en la competición de Data Science Bowl 2019. Como recordáis, en el último meetup con Gilberto Titerix, dijimos, venga, vamos a juntarnos todos a ver quién queda mejor en esta competición. Nos juntamos en el Slack, elegisteis esta competición y el mejor clasificado fue Alejandro, que además de una medalla de plata en esa competición, se lleva otra Galaxy Tab A7 para él. Pues muchísimas gracias, Alejandro, por participar. Muchísimas gracias a todos vosotros por venir. Muchísimas gracias, Jaugen, por haber estado con nosotros. Y hasta el próximo meetup.
Muchísimas gracias a todos, Jaugen, a todos. Gracias por haber venido. Nos vemos en el próximo. Chao.
Yeah, thanks,
Chao.
everyone.